dependent on what we're going to be doing next. And what we're going to be doing next is a linear regression. Which you may have done before, like a line of best fit, or a regression line. And it's used to make predictions based on the data. What we're going to be using is we're going to be calling it the least squares regression line, which, believe it or not, we're going to even abbreviate it, LSRL. And it means the same thing. It's this regression line, this line of best fit. So let's just give kind of an example. Okay, we'll review a scatter plot. Got your X and your Y values over here. And we always give them a name. Notice in the calculator you can't really graph it unless you have a name. That's good, because we need to have that. And let's say our scatter plot was negatively, and more of like a linear, pretty strongly negative there. And this line that we draw, if you were trying to like draw this line in, you would try to make it as close as possible to all the points. So I kind of wanted to go right down the middle of my points. Now when we do this, the calculator will definitely be giving us the exact line, and we'll be talking about how to calculate the exact line. But that's basically the idea. You want it to be as close as you can to all the points. And this line of best fit, or LSRL, least squares regression line, is your predicted value. It's kind of like what you would assume would happen if you were kind of make a general statement about the graph or about the scatter plot. You would kind of follow this line here. Notice how certain values land perfectly. Like this one right here landed perfectly on the line. Where there are some other ones that are farther away from the line. Like, for example, this line right here, or this point right here. The residual is how far away the point is from what was predicted. So basically, when we look at this point right here, technically, for this X value, what was predicted was all the way up here. I'll circle. That's kind of where it's predicted to be. But it's actually a lot lower than that. What should happen is, if we have to calculate a residual, the residual is the Y value minus the predicted Y value. So don't let that Y hat with a little caret on top. Don't let that scare you. It's what the actual value is minus the predicted value. And an easy way to remember this is AP. You're taking an AP class, actual, predicted. So let's say that this point right here hits at 5, and this point here has a y value of 3. What would the residual be? You would take the actual value, which is that lower one, the 3, and take away the predicted value, which is the 5. And you can get a -2 for a residual. What would happen is some of these residuals are going to be negative, and like the ones above this line, for example, if you look at the line, this one from up here, this is going to be a positive residual. The idea is that the residuals, if you sum up all of the residuals, it should equal 0. It should balance out. We should have a couple of these points above the line, a couple of these points below the line. This one on the line actually has a residual of 0. It's perfectly on the line. Residual is kind of like your error, how far your line is from those actual points. Remember, we want that line to be as close to all of the points as possible. Another thing to take into account is that let's say these x values that we're using in this graph range from like 30 in our scatter plot and maybe 40, 50, and they end at maybe 60 over here. This line that we drew, this best fit line, is trying to give us some way to predict what's going to be happening. We can only predict within the range of the points we're given. What this means is we're using points from 30 to 60. Okay? We don't actually want to say what happens when the line would be continued, and can you predict what would happen at, let's say, 90? Okay? When you go out of the range, when you're trying to estimate what would happen out of the range, it's considered extrapolation. So trying to estimate what would happen at, let's say, 90 is considered extrapolation. And what ends up happening is that ends up being very false. So we try to avoid extrapolation because it's outside the range of the data. So we want to avoid this. It's usually results in an incorrect answer or an incorrect prediction. Now, that's not enough for you. Let's talk a little bit more about how you get this.